Kia ora everyone, and welcome to this webinar. We're just going to give you a few minutes to come in, and sorry, apologies just for the slight delay in starting. It's been an interesting morning here in Silverdale, Red Beach. We've had power cuts, and then I was getting my backup all sort of sorted, and as soon as, of course, what happens, as soon as you get your backup sorted, it stops, the power comes back. And so we're back to normal. So we're going to get started. Thanks so much for joining us today. Kia ora, my name's Craig Young. If I haven't met you before, I'm the CEO of 22Apr12. And with me today, Richard Mooney from Vodafone New Zealand and Matt Hayes from Ciena, who's currently in Sydney. And we're hoping to see him sometime this year. So that would be great now that the borders are open. So I'm going to dive straight into it. We're talking today about international telco and data center trends. The use of data and the amount of data being used is increasing every year. I mean, we saw it last year. The TCF have released some stats recently around data increasing by 22%. And I've just had a question come through saying that someone can't hear anything. I'm presuming other people can hear me, otherwise they haven't put a note up there.
So. Yep.
Yeah, cool.
I can hear you.
Yeah, okay, so I must be okay then. All right, well, we'll keep going. I'm sorry, Venus, it must be something at your end. Right, so so data centers are being built in Aotearoa, New Zealand, remarkable speed, and we're getting these huge hyperscale data centers. There's a couple being built up here in Silverdale, just where I live. There's some big cranes, and Canberra data centers are building their huge data center up here. So we're looking to see some real big shifts this year. You haven't come to hear me, so I'm going to hand over to our first speaker, who is Richard. Actually, just let me tell you what's going on today. So Richard Mooney will speak first. He's the Chief Strategy Officer at Vodafone New Zealand. He'll talk about international telco trends, and then we'll hand over to our international speaker. Oh, that sounds fancy, Matt. From Ciena, we'll talk about data center trends, and then I'll do the Q&A. So look, just to remind you that as we go through today, if you have any questions as you go, chuck them in the Q&A. It's at the bottom there, the Q&A function on the screen. I have left it open so you can comment on the questions, and you can also vote them up and down. So you'll see them as they open. So if you think one of those questions is incredibly interesting and you want it to move it up to the top of the list to make sure I ask them, then make sure you vote for that. And that'll be how I watch for it. So without further ado, I'm going to hand it over to Richard Mooney, who is the Chief Strategy Officer for Vodafone New Zealand. And I'm going to give Richard access to controlling the slides. So Richard, over to you.
Hello, everybody. Great. Thank you, Craig, for that introduction. So yes, as Craig mentioned, I'm going to talk through some of the main telco trends we see internationally. And as we run through, talk through how we see it evolving in Aotearoa. Just as a quick intro, so I'm now coming up to 2 years at Vodafone New Zealand, previously at Liberty Global and then also Vodafone UK, but broadly 20 years in TMT across Europe, Asia and Australia. I plan to run through the slides fairly quickly. I always find that the Q&A is more interesting. And so, yeah, so I'll aim to get through this in about 15 minutes and then Matt will take over. So in terms of the big three trends, the key trends that we're going to focus on, kind of run through today. So the continued growth and demand for data, as Craig mentioned, and that is very much projected to continue. So just a quick run through of what's driving that demand for data and how we see it changing over time. The second area is the increased role of hyperscalers. So as Craig mentioned, that there's new data centers that are being built in New Zealand right now. There's a really, I think this is probably one of the most interesting areas that we're seeing internationally, in that there is an increasing convergence between cloud and telco infrastructure. We're seeing a large degree of collaboration between operators and those hyperscalers, and we'll talk through some of the some of those examples. And then finally, you know, how do we see 5G and the role of 5G over the next few years in terms of its growth and use cases. In terms of the total demand that we're seeing, so the growth has been remarkably consistent over the last 10 years across both mobile and fixed, but also consumer and enterprise. Mobile's growing at, my numbers growing, say, 40% a year compared to the 20% that you quoted earlier, but remarkably consistent over that period. Fixed also at 46% over the period. And then over the last few years, it's slowed slightly, and this is definitely a trend that we're seeing internationally. These numbers are all for New Zealand. Just because the numbers are getting so big, to maintain that kind of 40% growth gets harder and harder every year. We've seen a slight flattening off in fixed, but mobile continues to grow at high rates. In terms of what's driving that growth, it's driven both by supply side factors and demand side. And so if I just go through mobile and fixed in turn, so on the mobile side, there's been a huge growth in capacity on the supply side, driven by 4G over this period, but also more recently in 5G, and we'll talk about that a bit later on. And then on the demand side, you know, I think the big trend over the last 10 years has been the proliferation and the growth of smartphones, which has allowed people to consume ever increasing amounts of video. The third kind of big driver on the demand side, particularly on mobile, has been the growth in FWA, and this is where New Zealand does actually lead the world, but we're also seeing that internationally, particularly in the US and some European markets. The FWA penetration continues to grow, and it's effectively taking demand off fixed networks and putting them onto mobile networks. On the fixed side, on the supply side, it's clearly been, you know, the migration to fibre, away from copper-based technology. So again, significantly increasing the amount of capacity that people have to use, and that trend is projected to continue. And again, kind of New Zealand does lead the world, or is certainly one of the leading markets in the world with the high degree of fibre coverage that we have. On the demand side, again, similar trends to what we've seen in mobile. So significant growth in video traffic, largely driven by the OTTs, which I'll come back to in a second. But also more recently, we've seen some significant increases in demand from gaming, and obviously working from home during the COVID times. This now means that, you know, pretty much, you know, we think close to 80% of total data or total traffic on our networks is video, and within that, actually, it's dominated by the big streaming sites, so Netflix, Google, and Amazon, who are responsible for the vast majority of that traffic. And what we're seeing, particularly in Europe, is a real debate now as to who should be paying for the network infrastructure. When there's so few players that are driving such a large amount of the traffic, is it right that telcos should be the sole players who are investing in networks, and should some of these players be contributing to the cost of deploying those networks? And this is a debate that's been going on for, well, ever since the start of the internet, but around net neutrality. But that debate does seem to be coming back, particularly in the European markets, where telcos have struggled to generate a meaningful rate of return on those investments, and they're looking forward to the next 10 years and the huge amount of investment that they need to do to maintain this growth in demand, and asking the question of regulators and governments as to, you know, is the ecosystem set up in the right way? In terms of future growth, so what will drive future growth? So again, if I just split it in terms of supply and demand, so on the supply side in mobile, 6G will come along, heaven forbid 7G, continued on the fixed side, continued growth for faster fibre speeds, both in consumer and enterprise. On the demand side, you know, we're seeing, and we'll come back to this when we talk about 5G, significant growth in the demand for IoT devices, increased quality of video, so moving to 4K, 8K, all of which drives demand for higher bandwidth. The growth of FWA, as I talked a bit about earlier, will continue. And then finally, kind of new use cases in terms of virtual reality and the metaverse will continue to drive the demand, both across fixed and mobile. In terms of the second macro trend, and as I said, I think this is a really interesting space where there's a huge amount that's going on, is the increasing convergence between the cloud players and the telecoms ecosystem. And we're seeing a large degree of collaboration between these hyperscalers and these cloud players and the telcos. And I think what's, for today, what's particularly interesting is that actually this is an area where we see many of these trends happening overseas first, and we'll come to New Zealand later, which gives us a chance to kind of learn from others' experience. The other point to me, I think, is I've listed 8 here. There's actually more, but we've got 8 here, and that not all of these activities are equal. And there's a definite sense that in some areas the hyperscalers are experimenting to see if it will work, whereas in other areas it's clear they see it as a long-term growth opportunity and are prepared to invest significant sums. So I'll run through these quickly. I think the first one is around edge compute, and land grab is maybe too strong a term, but there's definitely a lot of interest and investment that is going into edge compute, and so this is the delivery of services closer to end users to reduce latency. And what's quite interesting about edge compute is it's an example of where the assets that telcos own and the assets that the hyperscalers own are complementary to each other. They both want what the other one has, the other party has. So in telco's case, I mean, clearly we have control of the network, but telcos also have a large number of locations of interest that are closer to end users in our networks, which would be of interest to the hyperscalers if they want to host services closer to those users. And then on the flip side, the cloud providers obviously have data center capacity, as Craig said, that they're currently deploying in New Zealand, significant experience in running those data centers. But also, I think probably most importantly, they have the customers who might be willing to pay for these edge services. And so what we're seeing is that there's a large number of partnerships between telcos, normally incumbents, but also other telcos and these hyperscalers who are kind of testing the appetite for these edge compute type services. The second area is around building virtual networks. I've got a slide dedicated just on this in a second. And again, it's clear that the hyperscalers are seeking to partner with telcos and to develop their own networks, and have acquired companies to help them do this. And the example that we've got here on the slide is Microsoft acquiring Affirm Networks a couple of years ago. Third area is in automation and AI, largely hosted on the hyperscalers infrastructure, partnering with equipment vendors such as Nokia, and then selling those services onto operators. Fourth area is in investing in infrastructure. I think an obvious example is SpaceX and Starlink, but we're also seeing Amazon, Facebook, and Microsoft in particular investing significant sums in subsea networks. They're driving a lot of that data growth that we talked about at the start, and actually it makes more sense for them to own that underlying network infrastructure than acquiring it from telcos in the case of subsea. We're also seeing some interesting use cases that AWS starting to offer private cloud services, private network services in the US. So again, clear kind of examples of them experimenting. Google historically had invested in a fiber network and then decided it was too complicated and too difficult and shut it down. The fifth area is, and again, I think this is an area where there's definitely more of an experimental feel. So some of the hyperscalers looking to offer services, telco services direct to consumers. So the example here is Google Fi in the US, which is an MVNO with T-Mobile that is run by Google and is doing reasonably well. The sixth area is around the shift to eSIM. So increasingly all devices will become eSIM compatible, and we've seen it in the latest iPhone, but also in terms of iPads and consumer devices such as Apple Watches, which potentially allows the hyperscalers to offer services direct to consumer in the future once eSIM becomes ubiquitous. The seventh area is around delivering content directly to consumers. So the obvious example here is Netflix, YouTube, but also Amazon Video. I think from a network perspective, what's interesting here is that all of these players are increasingly looking to cache that content closer to end users to improve both the experience for customers, but also to minimize network costs from transporting that content to their customers. And then finally, platform models, particularly, the example here is around Amazon Alexa and IoT. In terms of how we see this play out, is that there's a large number of partnership models that seem to be occurring. So most, these are European players apart from Etisalat, but we've seen a whole, not a month goes by without a new kind of partnership agreement between some of these telco players and the hyperscalers. And the areas that they're partnering tends to be around storage and computing. So cloud and partnering to provide public cloud services to, say, enterprise customers. Edge, as I discussed on the previous slide. Comms and collaboration, so UC. Data analytics, so partnering with the likes of Google on data interrogation. Provision of IoT services. And then the other area is in network virtualization. And so this is reasonably nascent, and I think is a trend that's worth looking into in a bit more depth. And that is partnerships between the operators and the hyperscalers to virtualize the network, effectively hosting all of the network functionality in the clouds. The examples I've got on the page here are both new entrants, so in Dish and Rakuten, but also existing operators such as AT&T. And so in terms of the new entrants, so Dish in the US is a new mobile entrant, Rakuten in Japan. The virtualization of the network allows them to deploy very quickly and cheaply. Particularly in Rakuten's case, they've now done this in Japan, and they're now looking to partner. They've got a partnership in Germany to do exactly this, but we'll also be looking at other markets. Dish is a bit more nascent, but they have a fully virtualized 5G network that's ready to go. And then, as I said, existing operators are also looking at it. So AT&T, who has moved its entire 5G core network into the cloud, and it provides them with greater flexibility in terms of the way they manage that core network, but also in terms of future cost savings. The final trend is around 5G and the growth of 5G. Now, I think it's fair to say the use cases are still reasonably nascent, and it's also, I think it's also fair to say that the evolution of 5G is going to be different to the prior G's technologies. I think the first point is 5G is much more viewed as a platform for future innovation. So the underlying technology for 5G provides new experiences, which we've captured on the slide here, but can broadly be grouped into three main areas. It provides faster speeds and greater capacity at a lower cost per gig. It allows for significantly more devices to go on to connect to the network. So within a given cell site, and then it provides significantly lower latency and potentially the ability to offer quality of service type guarantees, which are detailed on the slide. And then each of these technology capabilities kind of support a large number of underlying use cases, which we've captured on the slide here. In terms of the main consumer use case, we see, or we've seen, and certainly the experience internationally, is that, as I said, it provides much more capacity at a lower cost per bit, and it supports the growth that we talked about on the first page. So it provides a significant amount of capacity, both for the use cases that we described on the first page, but also around things like FWA at a much lower cost. And that seems to be the kind of the predominant use case currently. However, most of the interesting use cases are in B2B, particularly around IoT, but also through the ability to offer, quality of service and dedicated networks. So things like private networks or network slicing. And those B2B use cases and monetization models are still evolving. If you think of a G cycle as 10 years, so 4G was 2010, 3G was the 2000s, 5G will be 2020. It's really the midterm of the 5G cycle, I think, that we'll start to see these B2B use cases and monetization models gain any sort of scale. And this is why I think it is quite different from the previous Gs, is that, and actually most of those use cases are much more on the B2B side of in terms of, there'll be B2B type use cases rather than being led by consumer, which is certainly different to the way, say, 3G and 4G evolved. Okay, and then so to summarize, the big three trends that we see are that continued demand for data, and that's projected to continue over time. The ever-increasing role of hyperscalers, particularly through partnership with telco operators, and over time, where we'll see. And then finally, the continued growth of 5G, particularly in B2B and those use cases. With that, I'll hand over back to you, Craig.
Thanks very much, Richard. Much appreciated. I've got a couple of questions. I can't type them in, but I'll have them for you. I'm going to hand over now to Matt Hayes. Matt is the Senior Director of Sales Engineering with Ciena, and he's going to be talking about the trends in data centers. Remember, people, if you have questions as they come up, chuck them in the Q&A, because I'll be asking them after Matt has spoken. So, Matt, I'm going to hand over to you.
Thanks, Craig. Kia ora, everyone. Good morning. As Craig mentioned, Matt Hayes, I'm based in Sydney, run the sales engineering team for Ciena. I'm going to double click on one of the areas that Richard discussed around data centers, and in particular, the data center interconnect market. As Richard mentioned, there's a huge growth taking place, a lot of amount of growth taking place, particularly in the New Zealand market. And I think the time is now for everybody to jump on the data center interconnect bandwagon. So let me just take you through a few slides here to talk about some areas that I'm seeing. So I'm going to discuss two areas, one around the market trends, and then I'm going to touch on some of the key technology trends that we're seeing across the market. And this applies locally as well as globally. Okay, bit of an eye chart, but I think the key message here is that there's a lot of applications out there, and there's a lot of applications that are driving connectivity, and a lot of applications that, in particular, are driving high capacity interconnect. So just to touch on a couple of these figures, $1.3 trillion spent on cloud services by 2025. I think we're already seeing a massive surge towards cloudification. Applications are now stored in the cloud. Enterprises are now moving to the cloud. And as Richard said, a lot of services and solutions are now being cloud-based. So Cloud RAN and virtualized RAN capabilities in 5G is a good example of that. Obviously, video is still an enormous use case in terms of streaming video traffic. And I think the recent pandemic and ongoing pandemic situation is exacerbating that challenge in particular. I think the next evolution of internet traffic, particularly from a cloud perspective, is going to be driven by gaming. There's a lot of new services that are being set up globally around dedicated gaming services and gaming cloud capabilities, particularly in APAC, where it is a very, very large market. Average home internet bandwidth is now roughly 650 to 750 gig per month, which is an astonishing figure when you compare maybe 4 or 5 years ago. Telcos were imposing download limitations in terms of the actual amount of capacity that you could or services that you could download. And then, of course, some of the newer applications that are being driven by 5G in particular. So IoT is a big emerging market, and I know that that's a growth area in New Zealand in particular, but also the connected car and the telemedicine markets we're predicting to grow substantially within the next 3 to 4 years. And the last data point there is that in the 2 years from 2018 to 2020, more data was generated than all of the data prior to that. So if you think about that, that is an astonishing amount of data and an astonishing amount of capacity that has been generated and utilized by enterprises, by consumers around the globe. Now, in terms of data centers and hyperscalers in particular, we are seeing huge expansion and massive construction of key global data centers within the market. You can see some of the data points there around 2020 construction points. If I just double click on APAC, in APAC actually the forecast is to cross around $100 billion worth of investment in the data center space over the next 5 years. And I think that a lot of that is based around the way that providers are scaling and the way that we're now utilizing some of the applications within the cloud space. Sorry, just let me click back here. And you can see that the growth of hyperscalers in particular is pushing upwards and upwards, and there's now over 600 data centers within the global market. And APAC is certainly one of the higher growth areas that we're seeing. Now, in terms of what's happening locally, New Zealand is a very hot topic at the moment. AWS is opening regions. Azure, Microsoft are opening data centers. CDC, Canberra data centers in Australia are also opening in New Zealand. But I think there's a really large push generally in the market space around sustainability. And Google are doing everything around the sustainability perspective in terms of matching the amount of electricity that is drawn versus the renewables that they utilize to commit to that sustainability model. There are obviously further data centers that are being built within New Zealand, in the South Island in particular. So as we see the growth of data centers, I think sustainability in particular is going to be a very key aspect and a key subject that drives the growth of some of these data centers across the country. If I just take a look at data center and interconnect growth trends, the top bullet point there really just points to what were the global content network providers spending, right? So in 2015, their CapEx spend was around $35 billion. That included infrastructure, so compute, storage, plus also networking, interconnect and intraconnect. In 2020, that rose to $103 billion of investment. That's a 24% CAGR. Now, we still see that investment profile on the same trajectory. So I suspect in the next 5 years that the CapEx spend by the GCNs and the hyperscalers in particular will certainly rise to hundreds of billions of dollars worth of CapEx investment. So what are the 5 key areas that are really driving that investment? So I've tried to highlight 5 areas that we see within Ciena, certainly within the ANZ market. I think these are huge growth areas. Craig and Richard in particular touched on a couple of these, but if I look at where some of these areas are intersecting, I think GCNs and the CSPs in particular are facilitating a lot of this data center growth, right? Cloudification of apps are pushing a lot of growth areas into that data center build. And of course, customers want resiliency and the data centers understand that. So there are multiple DCs being built in different parts of the country which require resilient networking connections. I think access bandwidth continues in an unabated growth pattern, both fixed and mobile. Again, Richard touched on the 5G growth, and we're certainly seeing a lot of areas where operators and hyperscalers are looking to invest within 5G in particular, but also the fixed network, right? From a proliferation of fiber, where in New Zealand, you guys are certainly leading the charge in terms of fiber access to the home and to the business. in Australia, NBN continues to drive a multi-technology mix platform, which enables some of us to benefit from fibre connections at our home. Some of us not. Unfortunately, that's not me. But ultimately, I think access bandwidth is really pushing a lot of the data center growth trends from a cloud and application perspective. We're seeing that on the third point here, we're seeing that data centers are now no longer the realm of global, centralized data centers. We're now starting to see the distribution of data centers move certainly into metro areas, but we're now seeing more of a proliferation around edge data center and edge compute. And again, I think 5G is driving a lot of that. But again, you know, when we move into some of these lower latency applications that Richard touched on, you know, ultra low latency or massive machine applications, then edge compute is going to be critical to lower the latency profiles of the application requirements. So we'll see a lot more edge compute and edge DCs coming into the market space. Virtualization continues to grow. So obviously SD-WAN and SASE are growth areas, but we're also now starting to see desktop as a service from a virtualization standpoint. So the cloudification of user environments and end user environments now being based within the cloud in particular. And the last point is around subsea. Now, of course, obviously New Zealand and Australia benefit hugely from subsea connectivity. A number of big players that come into the subsea world with Southern Cross and Highwiki and TGA, etc. So there's a lot of interconnect that takes place within the subsea and the data center partners in particular. And we're also starting to see now in certain markets where the GCNs are partnering with the local CSPs to deliver connectivity terrestrially to interconnect across subsea systems. So again, that could be an opportunity and a partnering model that grows outside of the APAC market. If I just move on now to some of the technology areas that I'm seeing, certainly within the data center, you know, the evolution of optics, the evolution of the chips, the CMOS that we utilize within the ASIC in particular. And you can see some of the data points there at the moment. If we sit in 2021, we're seeing the majority of the ASIC is built on 7 nanometer CMOS, which allows us to really operate around that 400 to 800 gig bandwidth capability. Form factors are being introduced. Smaller form factors are being introduced now to enable faster consumption models and more distributed consumption models. But as we move into 2022, 23 and beyond, we'll certainly start to see the use of 3 or 5 nanometer CMOS technology that's now being worked on and ratified within labs globally, which will enable us to utilize and build you know, much more capable 800 gig bandwidth capabilities, but moving into that 1.2 to 1.6 terabit optic range. And again, you know, form factors will mostly be pluggables in particular. From an Ethernet speeds perspective, you know, the predominant speeds that we're seeing now are around 100 gig. We're starting to see 25 gig and 50 gig come into it, certainly within the 5G market space around edge connectivity. But there is a big push, and I have a slide coming up in a second around 400 gig rates of adoption. And the market is now really driving towards that 400 gig speed. But again, you know, as we start to evolve the data center and the optics technology, that will then proliferate into the Ethernet world, and we'll start to see speeds of 800 gig E coming into the market around the mid-20s timeframe. And I mentioned consumption models. So there's a lot of work that's been taken place in the market, in particular around coherent pluggables using QSFP DD formats or CFP2 DCO formats, which really offer a variety of technologies, but also offer a variety of consumption models for end users, whether it's a single span DCI application or a longer range metro, or even driving regional and backbone traffic across a pluggable architecture. A number of different facets that can be utilized if you're looking at integrating into photonic networks. But certainly, the ability to run large-scale capacity networks photonically using plugs is certainly something that is being utilized by our customers today. And if I just touch on 400 gig in particular, we are certainly now starting to see 400 gig adoption. We are starting to see that the early adopters are really coming from the aggressive 100 gig adopters. You'd expect the big hyperscalers to be looking at using 400 gig, which they are. Microsoft in particular, big proponent of ZR. So they are utilizing 400 gig E within their DCs. We're starting to see router ports now driving 400 gig bandwidth capacities, which is driving the demand from a transport and from a DCI perspective. In the international market, we're seeing operators like Colt and Windstream offering wholesale 400 gig E services. Deutsche Telekom have moved into 400 gig E for its customers on pan-European services, and that's an upgrade from their traditional 100 gig. And in the ANZ market, Lumia in Australia, a utilities provider, are offering 400 gig E services, and of course Vodafone locally here. There are some efficiencies to be had, obviously, from a cost per bit perspective, and I think there's some large enterprises that will look to adopt that to gain some of those operational efficiencies. But I think that the majority of the 400 gig services will start as specials, i.e. point-to-point services. But you can see that on the two graphs on the right-hand side there, that we really see the adoption rate of 400 gig and the crossing point of 400 gig and 100 gig around that 2024 timeframe, where the increase of 400 gig E services and transceivers in particular within the DC will start to overtake that of the 100 gig market. And of course, a lot of that comes down to cost. And as we drive more innovation within the optical market and the Ethernet market in particular, I think that we'll see a lot more efficiencies coming through from a cost per bit perspective that will drive the adoption of 400 gig E as a service. Okay, in terms of just summarizing what I've talked about, and then we can stop and go to any Q&A that may be out there. Just to echo what Richard was saying, data center growth and interconnect in particular are driving investments, huge investments from not only the enterprise, but utilities, governments in particular are looking to adopt more and more data center capability and growth in particular. Cloudification continues, and it will not stop. It will continue to grow, and we'll see more and more applications now moving to cloud-based architectures, which will drive the requirements for on-ramps into platforms like Azure and AWS, Google Cloud, etc. Consumption models are changing, and these are driving data center architecture models in particular. So again, if we think about the 5G space with vRAN or Cloud RAN architectures, a lot of that is being pushed towards edge compute, specifically to look after the requirements around low latency applications, URLC applications in particular. But of course, IoT is also driving a lot of cloudification applications and consumption models there in particular. The the GCN growth and the interworking with CSPs in particular, I think, is driving high-speed capacity models and fueling expansion in particular. And 400 gig is coming. It's absolutely coming, and I think everybody needs to be ready for that market in particular, because it will start to overtake 100 gig in the next 18 months or so. So with that, Craig, my slides are done. I'll just advance one more and hand back over to you for any Q&A.
Thanks very much, Matt. Fascinating, just lots of in-depth information in there. And I've got a quick question for you. Some of those gig E speeds are pretty mind-blowing. So where are the constraints going to be, you know, if you go to that sort of size gig E's within your data center, where are your constraints going to be going forward for users? Yeah,
that's a good question. I think, you know, there's a couple of areas, like from a data center interconnect perspective, we've always really traded and transacted in those kind of speeds, you know, particularly when you're talking optical transmission technology. So, you know, currently the leading market speeds are around 800 gig, although we're seeing experimental wavelength rates around a terabit to 1.2 terabit mark now. Of course, that drives the adoption of Ethernet service rates, which sit as a service within the transport architectures. And I think a lot of the constraints will be really based around the equipment that is used to interconnect the 400 gig E services. And as I mentioned, you know, the router vendors, Cisco, Nokia, Juniper, ourselves, we are all investing in 400 gig E capabilities for those platforms. But of course, internally within the data centers, compute platforms, server platforms have always really transacted in very high speed Ethernet capabilities as well. So I think 400 gig is already being utilized quite extensively within the data center itself.
Cool. I want to show a slide and ask Richard a question. I'm just going to show you this one. Make sure I've got it up there. Right. This is the mobile and fixed data usage. It's a very quick question, Richard. Is the fixed wireless access data included in the mobile or fixed category here?
Question, it's in mobile.
It's in mobile.
Yeah.
Right.
Yeah.
Okay, easy done. So here's a much more tricky question for you then. Where are the risks with telco in this space, you know, around the hyperscalers? So the hyperscalers looking to enter the world of telco without partnering or providing solutions that aren't reliant on the telco in the market. I was thinking about this as well. How do you deal with that encroachment?
Well, I think I think you're right. There'll be so if you look at some of those the examples I gave earlier. So I think, say, the MVNO example or the eSIM example, like, we would welcome it. But actually, if you look at a lot of the other examples I put up, that it's much more partnership rather than, and by that I mean, so true forms of partners, but sometimes it's the telcos acquiring stuff from the hyperscalers, and sometimes it's the hyperscalers who are customers for the telcos. But so if you look at the vast majority of them, it's working together. There's a handful which you could categorize as, you know, not requiring the telcos at all. But even something like MVNO, there needs to be a host operator, right? And so we don't really see that much of a threat in terms of them coming in and targeting services that we already do. Like, the vast majority of those use cases that I presented are partnerships.
Okay, well, that leads on
similar, and that's similar to the like the discussions we have with them. Actually, it's you know, all you know, the discussions we've had with them, both, you know, in my current role here, but also in prior roles, is, you know, there's a long list of things where we can work together. And you know, like the edge compute example that I talked about, there's things that we have, which are of value to them, and there's things that they have that are of value to us, and the discussions have been very much of that nature.
Well, that leads me on to asking a question I have based on some conversations with the media in the last 2 days.
Yeah.
So about that partnership. So looking around at the current move by yourselves and Spark around towers.
Yeah.
So does access to towers and spectrum not remain a competitive asset for traditional telcos going forward?
So I think so towers, yes. I think that, you know, both us and Spark and many other telcos globally have divested of their towers. They've all, you know, there's different ways in which it can be done, but it's you know, this is me going on, it's a trend that's been going on for about 10 years, and I think it's the realization that just the towers, so the passive part, spectrum. I'll come back to spectrum in a second, but treat it separately. But the passive part of the network is less important in differentiating from a network experience perspective, and that ultimately these assets are better owned by third parties because they can operate them more efficiently, and they're more incentivized to drive future sharing. And that's a trend that's played out, you know, in the US, Europe, Australia, and has now come to New Zealand. Spectrum is separate though. Spectrum is does still have a role to play in our ability to differentiate, as does the active component of the network, and also increasingly the core part of the network, which you know, if you look at some of those 5G use cases, are dependent on having, you know, say a 5G standalone core, which provides differentiation between the operators.
Cool. I'm not sure which one of you wants to answer this question, but if video is the big driver for networks, what role do existing geo, so that's geographic, geo satellites and proposed low Earth orbit satellite networks play, given existing or lower infrastructure costs relative to the required density for similar performance on 5G networks? Who wants to go first?
So is this video, are you talking about video delivered by, let's say, a Sky satellite versus video delivered on fixed infrastructure?
I think this is just generally, if video is driving growth,
yeah,
how do the new satellite networks, given they've got lower infrastructure costs, play, given the 5G, you know, you've got the required density for that. So it's just general video.
General video. I think, well, so for 5G and kind of the fixed fiber networks we're going to provide significant amount of capacity for the delivery of video, and we see that today. The issue is sometimes on those networks, and I think I wasn't here at the time, but I understand during the World Cup in New Zealand, ensuring that the networks are sufficient capacity whenever there's a live event. That's the you know, whenever there was, when I was in the UK, you know, Amazon started won the rights for the Premier League and broadcast 20 games all at the same time. And it's ensuring that there's sufficient capacity in both the fixed and mobile networks to cope with that amount of data all at the same time. But increasingly, it's going to become less of an issue as capacity increases, as we talked about. For the likes of Starlink, I don't know. I think I'd have to look into whether what sort of impact it has on them. But you know, it's a question of there's still a role to play for broadcast networks, so things like traditional satellite, DTT, particularly for live events and the free to airs, the pay TV channels. But increasingly, you're seeing a lot of that content move to kind of IP based delivery, and I think that will continue over time.
Cool. Matt, did you want to take a punt at this question?
Yeah, I mean, look, I can certainly talk about it from a LEO sat perspective, because we're seeing a lot of LEO sat operators coming into markets, and in particular, I think their business case tends to start with coverage, right, as an alternative play to mobility and fixed, mobility meaning 4G, 5G networks. I think as the technology plays out and the interconnect in particular, because of, let's not forget that LEOsat is a great access medium and a great access technology, but it still requires backhaul, right? So it still requires some interconnect within the CSP or within the hyperscaler domain to backhaul back to data center and content engines. So, ultimately, I think LEO is going to be another good technology medium. I think it will be utilized for, let's just call it the traditional triple play traffic. And I'm going back 10 years or so when I mentioned triple play, but it'll be voice data and video capable for sure.
Yeah. Look, I'm going to stick with you, Matt. You can take another punt at this one, but most of the trends we've talked about are specific to enterprise and businesses, and we specifically were talking about that. But we've got a question here. What do we see any trends apart from video or working from home for consumers?
For consumers, yeah, I think, and I see it in my home, especially when I'm trying to work from home. My son hogging the bandwidth on online gaming. I think online gaming is going to drive huge capacity demands locally. I think the trend of home working or hybrid working will continue. I know that some of us are now back into office environments, which is great, but I think a majority of the workforce relocated during the pandemic, right, and will continue to still work in that remote based application. So again, it's going to be a consumption model that is applicable across residential, across the enterprise from a residential perspective, as a home worker, but also I think gaming will certainly come on stream quite significantly within the next 2 to 3 years. Yeah.
Richard, did you want to add anything to that?
So gaming, but also I think kind of virtual reality, metaverse type applications, like more on the kind of the medium term. We're definitely seeing, so I come back to what we're definitely seeing on our networks, a increase in traffic due to gaming right now.
Interesting, isn't it? Just time for 1 or 2 more questions. I'm not going to. There's a question about RCG cell towers, but I think we might take that up at the Rural Symposium actually. But Richard, just since you're a retailer, when do you expect consumer devices to cope with these sort of fast speeds? I mean, devices at home or routers are capping out at a G. So,
yeah, good question. I mean, on the mobile, I know more on the mobile side, to be honest, than the fixed side. But on the mobile side, you're seeing, with every evolution of the iPhone, it comes with new band, new, obviously 5G capable, and so every passing year, like an iPhone now can cater for so many of that's the spectrum bands and 5G. In terms of fixed CPE, I couldn't tell you. It's not my expertise. Matt, maybe you know more.
Yeah, it's probably one also for Chorus and Hyperfiber. But yeah, Matt.
Yeah, that's right. Yeah, I think fixed networks we're certainly starting to see speeds of over a gig being offered within different markets. Certainly within Europe, in certain economies, I think certainly in the UK, speeds of over a gig are definitely being realised from a fixed perspective. Technology advances in PON and HFC are driving the capability to drive up to 10 gig per home, I would say. The operators are now starting to offer more flexible plans around higher capacity speeds. But again, I think it will be a mixture of gig and 10 gig services. Certainly 400 gig or 100 gig and above, or 10 gig and above, will certainly be the domain of the enterprise, connectivity models for the enterprise, and also within the infrastructure environments. I can't quite see 400 gig coming to our screens just yet, but it's a nice proposition. Right?
Well, certainly not in Australia with your mixed model, right?
Yeah. So the other thing I should add is on FWA actually, is that we do see, and this is, as I said in our session, in my slides, that kind of New Zealand is one of the leading markets in the world in terms of FWA. But one of the issues on 5G has been the cost of FWA CPE, 5G CPE. But what we're seeing a large number of particularly US players who have got some very ambitious targets around 5G FWA, which will help grow that the ecosystem around the CPE for FWA, which should lead to cost reductions and greater availability of that CPE.
Cool. Hey, well, I just want to say thank you very much to Richard and to Matt for their presentations this afternoon, and just remind people that if you didn't catch all of it, it will be putting the video up on the YouTube channel and for the 2N's YouTube channel, and people will be able to watch it. Also, just watch out for a pilot launch before the end of the month for we're getting into special interest groups, and we're looking to launch one on cloud users and hyperscale data center before the end of April. So if you're interested in the space, special interest groups are a new thing for us, so we're going to try that out. And then finally, this isn't going to be the last webinar we'll ever run, but given the changes in the way we're dealing with the pandemic, particularly in New Zealand, we're looking to move back to having a mixture of webinars and in-person events, probably in May. So if you've been hanging out to network and sit down and stand around and have a chat over a glass of wine or a beer, look out for that coming towards the end of May. And of course, in June, Vodafone is also one of the key partners for the Rural Connectivity Symposium, which will be the first time since 2019 we've been able to get together and look at, we've been talking about satellite today, LEO, and 5G. These are huge technologies, going to play a huge part in rural connectivity in the future. So thanks very much again, everybody, and have a great day, and mā te wā.